Hi, algebra students. Mr. Rising here once again. I'm on a roll today. I'm just going to bust out 4 lectures at once and just call it good. Hey, this is lecture 6.5 in your algebra textbook. It's about multiplying polynomials. And again, the beginning of the chapter we started with properties of exponents. Again, x times x is x squared times x is x to the third. And we add exponents when we have the same base. And you're going to be practicing that skill a lot. Remember, please follow along in your book. If it's any help, pause the video, go through it, look at the example, take a look at another example, try a practice problem. But we're going to really do the heavy practice in class together where we can help each other out and get support. So, multiply. Multiply what? Oh, in this example, we have two monomials being multiplied together. And so the process of doing this is basically we're grouping everything and multiplying. For example, 6 times 3. Oh, okay, those are the coefficients. 6 times 3 is 18. That also means y to the third times y to the fifth, and that becomes y to the eighth. So 18 y to the eighth. Here's another example. So again, the numbers get multiplied together. The variables get added. The powers get added because they have the same base. And then so the m and m squared becomes m to the third. N squared and n to the first becomes n to the third. 3 times 9 is 27. So take a look at that. If you want to put these examples in your notes, it's a great idea because that's really what you're going to be doing with all these problems. And again, just that reminder, when multiplying powers with the same base, keep the base and add the exponent. Now, when you multiply a polynomial by a monomial, you use the distributive property. Well, what does that mean? What that really means here is when I've got 6pq times this binomial, it means I have to distribute the 6pq to both the 2p and the negative q. And when I do that, I get, oh my, look at this. This is just gorgeous. Actually, 6 times 2 is 12. P and p is p squared and the q. And over on this side, 6 times negative 1 is negative 6. P, I got a p, right? 1p, p to the first, and q is q squared. So again, here's another really good example of, you might want to put in your notes to say, hey, what is going on here? So again, pause the video if you need, put the example, but you can see how all the factors get grouped and multiplied together. Another example. Now we've got a fraction. Are we afraid of fractions? Heck no, we love fractions. Step number 1, distribute the 1/2 x squared y to both terms. Okay. Step 2, group the like bases together. Here we go. Oh my gosh. Right? Now look at it. It's really not that bad. 1/2 times 6 is 3. X squared and x is x to the third. Y times y is y squared. And again, you do the same thing on after the addition, right? Because I can't actually combine these until I know what the variables are. And long story short, 1/2 of 8 is 4. X squared times x squared is x to the fourth. Y times y squared is y to the third. You're just applying these things together. You're combining these things in a way without knowing actually what the inputs are. A couple of examples. Now the fun part. When you start to multiply polynomials by polynomials. The first example is a binomial times a binomial. You're going to get really good at this if you do it enough. All right, again, you're going to use the distributive property, but you're going to use it more than once. What I mean is this. You're going to take x plus 3 times x plus 2, and you're going to distribute the x to the x plus 2 and the 3 to the x plus 2. All right, and so when I do that, I simplify this out. You notice I get x squared plus 2x plus 3x plus 6. And of course, then I can combine like terms because 2x and 3x are x to the first power. 2 and 3 is 5. I get 5. Interesting, right? See what I'm saying? You have a middle. And that's what's really interesting. Now, this is what I call double distribution because you've got two things you're distributing. Another way to do this is with the FOIL method. And please write this down because this is what you'll hear math. If you go to another school or go somewhere else in the world, they'll say, well, FOIL it. What does FOIL mean? When you multiply binomials together, first, the first terms, x times x is x squared. Second, you do the outer, x times 2, 2x. Then you do the inner, 3 times x, 3x. And then you do the last terms, 3 times 2 is 6. Then you combine anything you can. Stacy, I think she's done. Hang in there, Stacy. Then you combine like terms, and again, you get x squared plus 5x plus 6. This is the exact same problem we just did. It's just another method. I'm leaving it to you. I will ask you to do the FOIL method. I'll ask you to do double distribution. But no matter what, you're going to get the same answer if you've done it correctly. Okay, so now just a few more examples. I've got s plus 4 times s minus 2. I'm going to distribute here. Actually, you know what? Let me just pull it out like that. There we go. I'm going to get s squared plus 2s minus 8. Let's use the FOIL method. S times s is s squared. First, outer, s times negative 2 is negative 2s. Inner, 4 times s is 4s. And then last, 4 times negative 2 is 8. And again, I can combine the terms in the middle. Negative 2s plus 4s is a positive 2s. So I've got examples galore, but note something here. Where's the other binomial? Well, in this example, the binomial is the same. So write it as the product of two binomials. There's a big error that students do here. They go x squared minus 16 or plus 16. Guess what? They've missed the middle because they just squared the first term and the last term, but they didn't actually combine the middles. So again, x squared x times x is x squared. First, outer, x times negative 4 is negative 4x. Inner, negative 4 times x is negative 4x. And negative 4 times negative 4 last is 16. Now when I combine these, you'll notice, oh yeah, the first one is squared. The last term is squared, but there's also a middle that you can't forget about. Okay, another example using the FOIL method, right? First I'm going to do 8m squared and m squared is 8m to the 4th. Then I'm going to do my outer, 8m squared and negative 3n is negative 24, m squared n. Easy. Inner, negative n times m squared is negative m squared n. And then last, negative n times negative 3 is positive 3n. And again, because these are both m squared n, I can combine them. Negative 24 and negative 1 is negative 25. I'm hitting my 8-minute mark. I got a little bit more. This one's a little more complicated. Yeah, so again, in this expression, the base is x plus 5, right? So when I square it, I've really got 2 of them there. All right, now the trickier one. So when you multiply a polynomial with more than 2 terms, you can use the distributive property, you can make a table, or you can do this vertical method, which looks a lot more like multiplying big numbers together. I would recommend using this distributive method. It's just more consistent. So again, what you're saying is, hey, when I'm going to multiply these together, I got to take the 5x and I've got to multiply it by the 2x squared, the 10x, and the 6, and then I got to do the same thing with the 3. So you end up doing like double distribution here. You need to go but again, long story short, it's really the same process. It's just another layer of the same process. And this is what a lot of life is. It's just, oh, I've done this before, now I got to do it again. I got to do my taxes, I got to do it again. I have to add another layer to it. Again, if you need to pause the video, you can do that. You can also do this with a table of values. And again, you're going to combine all the like terms and you're going to get the same thing. Feel free to pause the video and read through this. It's also in your textbook. The last example, okay, looks more like traditional multiplication, where you take the 3 and multiply it by the 3 terms. Well, that's distribution. Then you take the 5x, multiply it by the 3 terms. Notice how you've lined up the degrees. Here's the to the third power, to the second power, to the first power, to the 0 power. And again, when you simplify everything out, you're still going to get the same answer. You know what? That's really it. Helpful little hint here. When you have m terms in a polynomial multiplied by n terms, so for example, if you had a binomial multiplied with a trinomial, you're going to end up with 6 terms before you simplify it. And when you're done simplifying, you may end up with only 2, but don't forget that when you start going through these processes. The last thing is just an example. And it says, hey, the width of a rectangle, like rectangle is length times width, it's 3 feet less than the height. And the length, right, is 4 feet more than the height. So what you're doing is we're saying, hey, the length is 4 more than the height, the width is 3 less than the height. I've got terms. I can multiply these together to figure out the area. And now it's basically an application of the problem where you can substitute the height of the prism to figure out the area of the base. Hey, that's it. That's an 11-minute lecture. I couldn't make it much shorter. But if you have any questions, we're going to, again, work on these examples in class. We're going to work together, use the book, help each other out. All right.